As an enterprise decision maker, you are not alone if you are struggling with critical AI challenges. Inefficient compute resource allocation resulting in underutilized and difficult to manage infrastructure. Lack of visibility into AI cluster health, leaving your business vulnerable to costly outages. Lingering AI model deployment cycles, stifling innovation and time to market. Whether you're in higher education, finance, energy, automotive, or manufacturing, Motus AI helps you do more with the resources you already have. Meet Motus AI, the DevOps platform built to streamline every part of your AI journey, from setup to deployment. Smarter resource scheduling. Make every GPU count. Most companies use just 38 to 43% of their GPUs during training and less than 1% during inference. That's a lot of wasted investment. Motus AI changes the game with intelligent scheduling that dynamically partitions your clusters for training and inference. All the way from partitions of a single GPU to massive 1,000 GPU clusters. You can bring new hardware online in 30 minutes or less and allocate resources in real time to match your actual needs. No more idle machines, no more long queues. In real-world use, Motus AI consistently achieved over 400% improvement in aggregate resource utilization. Proactive 24/7 smart monitoring. AI clusters are complex, and even minor glitches can lead to costly downtime. During Llama 3 training, almost half of system failures came from GPU and memory issues. Motus AI offers always-on monitoring across GPUs, networks, storage, and other system health metrics, detecting anomalies in real time. If something goes wrong, it spots the issue instantly and automatically migrate workloads, often in under 90 seconds. Your operations keep running smoothly without missing a beat. Motus AI transform your IT from reactive firefighting into proactive mitigation strategy. Rapid AI deployment in 3 simple steps. Traditional model deployment requires complex cross-team coordination, often consuming weeks of valued time. Motus AI empowers your AI algorithm scientists with a streamlined 3-step process. 1. Instant setup. Launch your dev environment in under 5 minutes and start coding right away. 2. Easy training. Submit jobs to Motus AI Smart Scheduler for up to 2 times faster training through automatic allocation of optimized resources. 3. One-click deployment. Roll out models as scalable APIs with zero downtime, with seamless integration into existing business applications. This reduces the development time by over 50% and helps you deliver results faster. Motus AI is designed for industry leaders who demand reliability and performance. Motus AI, built for performance, proven in the field, ready for your team. In AI clusters, users often occupy entire GPU cards with low utilization, wasting resources. Motus AI addresses this by using GPU MIG and partitioning technology to divide a single card into multiple instances. This enables multiple users to share one GPU, significantly increasing resource utilization. As an administrator, log into the platform and open the Resource Group Management page. When creating or editing a resource group, you'll find options to enable either GPU MIG or GPU fractions. If you choose GPU MIG, the system supports NVIDIA's standard MIG templates and automatically splits each GPU card into multiple instances. Motus AI allows different splitting configurations for individual GPUs on the same node. meeting finer-grained scheduling and resource allocation needs. If the standard MIG mode doesn't meet your business requirements, Motus AI also provides more flexible GPU fraction. It includes two modes: GPU reuse mode. Multiple tasks can share the same full GPU card simultaneously for lightweight model development scenarios. Motus AI supports up to 64 concurrent tasks per GPU, significantly boosting resource utilization. GPU memory isolation mode supports fine-grained GPU memory partitioning with a minimum unit of 1 GB. By allocating independent memory space for each task, this mode effectively avoids memory contention between tasks and ensures stable task execution. After configuration, users select pre-divided GPU resources for tasks instead of entire cards. This enables simultaneous fair access to accelerated computing for more users. In multi-user AI environments, resource overuse occurs. Some users hoard computing resources, causing shortages, or consume excessive storage, depleting shared capacity. To ensure fair distribution and prevent overconsumption, Motus AI offers resource quota management. Administrators can assign quotas by user or user group, enabling precise control over individual or team resource budgets. This effectively mitigates unexpected costs from uncontrolled usage. After logging into the platform, administrators can go to the User Management, User Groups page. Firstly, create a new user group. Then select this group and click Modify Training Quota to set resource limits under training tasks, including storage, image, CPU, and GPU usage. Click Modify Inference Quota to configure resource limits for inference workloads, including memory, CPU, GPU, and storage types. Once group-level compute quotas are set, it is necessary to further assign resource limits to individual users within that group. Go to the Users, Quotas, and Permissions page. Select a user and click Adjust Compute Quota to set personal training quotas, including CPU and GPU resources, with optional card type-based allocation. Click Adjust Storage Quota to set personal storage limits, including image count and storage capacity. Click Adjust Permissions to configure personal access rights, such as enabling or disabling download capabilities, model copying, and emergency task permissions. Once user and group quotas are configured, Users cannot exceed the lower of their individual or group quotas during model development, training, or inference. By setting upper resource limits, Motus AI systematically prevents resource abuse and uncontrolled costs, ensuring stable, fair, and efficient system operation. As clusters grow complex, administrators face delayed responses to user-reported issues like service outages and memory shortages, lacking full operational visibility. They urgently need real-time system awareness and historical usage data to optimize resource allocation, preventing both idleness and over-provisioning. Motus AI addresses these needs with centralized monitoring and reporting. After logging into the platform, administrators can access the following monitoring features in alerts. 1. In the Devices page, supports viewing CPU and GPU usage with multidimensional metrics for comprehensive monitoring. 2. In the Nodes page, administrators can view node performance, monitoring information, error diagnostics, and log analysis. 3. In the Storage page, provides monitoring of shared storage and node-level storage, including current status, usage, and individual consumption details. 4. During the monitoring of these cluster devices, abnormal conditions can trigger alerts. The system supports customizable alert policies, allowing administrators to define alert thresholds and notification methods. Once a threshold is reached, the system automatically sends alerts to operations personnel, enabling timely detection of issues and preventing service outages. In the reports, administrators can analyze usage from multiple dimensions, resources, tasks, users, storage, and alerts across different time periods and users. 1. Resource Statistics page. View CPU, GPU, and memory usage or utilization by cluster, resource group, or node. 2. Task Statistics page. View total task counts across different time intervals. 3. User Statistics page. Query resource usage by user or user group. 4. Storage Statistics page. View storage usage trends across time intervals. 5. Alert Statistics page. Analyze alert distribution and resolution status. These statistical reports can be exported, helping administrators analyze historical data and forecast future trends. Motus AI tackles operational inefficiency, waste, and security risks via real-time monitoring, root cause analysis, resource optimization, and data insights, boosting cluster stability and cost-effectiveness. Traditional AI modeling requires local coding before cluster validation, creating fragmented workflows and environment mismatches that cause training failures. Motus AI solves this with an all-in-one workspace, enabling online environment setup, coding, and execution for rapid development and debugging. After logging into the platform as a developer, navigate to the Build Workspaces page. When creating a development environment, you can select custom images for different frameworks to meet various model development requirements. You can also mount files or datasets and choose access methods such as node cache or direct use. 1. Node cache downloads the dataset to the compute node's local storage for faster access in subsequent uses, improving training efficiency. 2. Direct use reads data directly from the storage directory. Once the development environment is created and running, the environment details page supports interactive tools like Jupyter and WebShell for direct model development. It also allows SSH remote connections for debugging, catering to developers' preferred workflows. During the development process, you can use visualization tools to monitor model training performance. If compatibility issues or missing dependencies arise during model development, you can quickly build a complete environment using commands. The built environment can be saved as a new image, allowing developers to reuse it later or share it with team members, reducing development time and increasing efficiency. The development environment also supports real-time monitoring of container performance, including CPU, memory, network, and disk usage. Once model development and debugging are complete, you can manually stop the development environment to promptly release resources. MotusAI's interactive modeling enables online development and debugging, addressing common challenges like inefficient debugging, high-skill barriers, and environment gaps. This transforms model development from rigid pipelines into dynamic exploration, boosting efficiency and cross-team collaboration. For AI developers running extended modeling tasks, unmonitored issues, example, resource shortages, risk training interruptions, while post-completion idle resources cause wastage. MotusAI's training module solves this through automated task submission, hands-off monitoring, autonomous issue resolution, and instant resource release upon success. After logging into the platform as a developer, navigate to the Build Trainings module. On the Create Training task page, you can select the image, required resources, and the model training script. Two types of training methods are supported: single-node training and distributed training. One, single-node training. Ideal for scenarios with limited resources or small datasets, allowing for quick development or iteration on a single node, lightweight and agile. 2. Distributed training, suitable for models with large parameters or extensive datasets that cannot be handled by a single node. Distributed training breaks through single-node bottlenecks, enabling scalable task execution. The Motus AI platform offers different distributed deployment options based on the framework type, allowing users to choose according to their needs. If a developer has a high-priority task that needs immediate attention, they can opt to enable emergency task mode, provided that the administrator has granted them the necessary permissions. Once the task is created and running, users can view real-time logs. Motus AI automatically flags and resolves anomalies during training. When an issue is detected on a node, the system removes the affected node and reassigns tasks to healthy nodes, maintaining progress without requiring a full restart. Upon task completion, the system automatically releases resources, removing manual effort and avoiding wasted resources. The Managed Training module enables efficient model development through standardized processes, automated scheduling, and intelligent resource management, addressing long task failures, idle waste, and collaboration barriers. Traditional model deployment requires complex environment setup, causing compatibility issues and inefficient maintenance due to difficult real-time monitoring and updates. Motus AI addresses this with diverse deployment options for rapid model deployment and full lifecycle management of services, streamlining deployment and maintenance. After logging into the platform as a developer, navigate to the Inference Deployment page. Multiple deployment methods are provided, including common deployment and custom deployment, to flexibly handle different deployment scenarios. 1. Common deployment. Simply select the model file path, resource limits, upper and lower bounds, number of instances, etc. to quickly deploy the model. 2. Custom deployment. It is also called image deployment. If users obtain pre-built model images from third parties, they can directly select the image file, along with resource limits and instance numbers, to quickly deploy third-party models. Both deployment methods support setting conditions for triggering auto-scaling, such as QPS, queries per second, and CPU usage. During actual service operation, when these thresholds are reached, the service will automatically scale to accommodate traffic demands. Once the service is deployed and ready, you can view its status, basic information, invocation details, and performance monitoring on the Service Details page. The platform also supports viewing detailed logs of service containers and online verification of model inference results. Additionally, rolling updates can be performed using A/B testing to validate the performance of different model versions. By offering multiple service deployment methods and comprehensive lifecycle management, Motus AI addresses bottlenecks such as low deployment efficiency, inefficient service maintenance, and uncontrollable iteration processes. This transforms AI models from experimental outputs into scalable, measurable, and manageable AI applications. Motus AI streamlines AI deployment through multiple methods and full lifecycle management, solving bottlenecks like inefficient deployment, maintenance, and iteration. This turns experimental models into scalable, manageable AI applications. After logging into the platform, users can go to the Inference Deployment module, select a ready service, and enter its details page. In the A/B testing section, a new version of the service can be created using the updated model. Once created, traffic can be split across multiple services for bucket-based experiments. The platform supports various traffic allocation methods: manual, image, condition. 1. Manual. Manually divide traffic among the services participating in A/B testing. 2. Image. Duplicate the master service's traffic to the test service. The response only includes the master service's results. 3. Condition. Determine the service to route traffic to based on the configured conditions. These flexible options meet a wide range of testing and validation needs. After completing the bucket-based traffic experiment across multiple versions, users can promote the best-performing service to production status, officially launching the new version and completing the model iteration. If, after deploying the new version, a critical issue is discovered in the live environment, the system also supports version rollback to the previous service version, minimizing business impact and ensuring smooth operations. Through A/B testing and traffic bucketing, Motus AI replaces subjective decisions with data-backed insights. Users can now make scientifically grounded decisions and implement smoothly roll-out model updates, guaranteeing stable and trustworthy deployments.